Today's exam question comes to us from the 2024 higher paper, and it's question 7, and it's all about bonding and how the halogens react. So the first one we've got is calcium reacts with chlorine to produce calcium chloride. I'm seeing calcium here, and we know that calcium is a metal. Because calcium's a metal and chlorine is a non-metal, we know that calcium chloride must be an ionic substance. So straight away when we're thinking of ionic, we're thinking about swapping, gifting electrons, so that we get a full outer shell. Explain. Now, the word explain, whenever we're doing exam questions, means, just like the Backstreet Boys, we need us to tell us why. So we need to see the word because, or some kind of explanation as to what is going on. Explain what happens to calcium atoms and to chlorine atoms when calcium reacts with chlorine to produce calcium chloride. So we've already seen this idea that calcium is a metal. So what exactly does that mean? It means it's got slightly too many electrons, is it wants to lose those electrons to get a full outer shell. And non-metals have got not quite enough, so they want to gain. We can use the periodic table to precisely say how many they want to lose or gain. Because if you remember, the group number tells us how many electrons are in the outer shell. Well, chlorine is a halogen, it's in group 7. So what that means is chlorine has got 7 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7. So that means it wants to gain 1. Similarly, if I look it up for calcium, calcium is in group 2. So what that means is it's got 2 electrons in its outer shell. So that wants to lose them. So calcium will lose 2 electrons. Now, the thing with electrons is electrons are negative. So if I've lost a negative, I become more positive. Just like if I cut out a really annoying negative influence on my life, overall my life has got better. So if it will lose 2 electrons to form a 2+ positive ion. Now weirdly, that's 2 marks, losing 2 electrons and forming a 2+ calcium ion. Chlorine will gain an electron to form a 1-, or you could even say Cl- negative chloride ion. Now, something's a bit fishy here because I've just said that calcium will want to lose 2 and chlorine will want to gain 1, and there's a bit of an imbalance there. So how do we resolve that? We have to remember that we don't just have 1 of each atom. There's loads of atoms. Atoms are really tiny, so if I have a pile of them, I have thousands and millions and billions of all these atoms. So the way that we resolve it is we know that calcium does want to give up 2 and chlorine wants to gain 1. So what that means is if I have 2 chlorine atoms, each of which can take 1. So 2 chlorine atoms are needed to react with each calcium. Explain why chlorine is more reactive than bromine. So again, this is our explain question. So we need to tell me why. Chlorine is more reactive than bromine. So it comes back to what we've just said here. We want to gain an electron when we react as a halogen. So let's draw these chlorines. Chlorine is in the 3rd period. So what that means is it has 3 shells. So those outer electrons are this far away. Bromine's a period below. So it's another period. Now obviously I've exaggerated that slightly, but what that means is I've got 1 more shell of electrons. So these outer shell electrons are much further away from the nucleus. So if I'm trying to catch that extra electron, remember the nucleus is positive, so that's what's going to attract that electron in. If I'm further away, it's going to be much harder for me to attract it in. Whereas this one here, chlorine, is much closer, so it's easier to attract it. I can even think, well, what happens if I had fluorine, which has only got 2 shells? That's going to really grab it. And that's why fluorine is one of the most reactive elements, if not the most reactive element, on the periodic table. Chlorine has fewer electron shells than bromine. This is where our explain comes in, because you'll notice this when we do exam questions, it's kind of and then, and then. So we've come up with our point, so what does that mean? Chlorine has fewer electron shells than bromine, so that means, therefore, the outer shell is closer to the nucleus. If that outer shell is closer to the nucleus, that means the electrons are more strongly attracted. Help if I can actually write. And therefore, gain an electron more easily. So it's more reactive. That's quite an advanced idea, that. By being further away, I've weakened the attraction to the nucleus, and therefore it's harder to gain that electron. And the final part of this question. We have the table below shows the boiling points of the 4 hydrogen halides. Describe how boiling points of the hydrogen halides change as the relative formula mass changes. So notice here we've got a describe question. If we've got a describe question, we don't need to say why, we just need to say what. So what we notice here, we've got a big negative number, and then we're slowly getting less negative. So we've got a trend here of increasing. But I mean, what on earth is going on here with the hydrogen fluoride? And actually, this is where 2-mark questions come in. When it comes to trends, means that it's going to be more complicated than simply one goes up. So we've got an extra bit to caveat what we've said. Our general trend is as the RFM, the relative formula mass, increases, the boiling point increases. And if this was a 1-mark question, that would be the mark. But because we've got HF here and things are a bit odd, okay, however, HF has the highest boiling point, or you can also say it doesn't follow the trend.